quick video on Hess's law. Okay, so starting with the law of conservation of energy. Energy cannot be created or destroyed, but only changed from one form to another. When I'm referring to energy here, I'm referring to heat energy, delta H, which is what we've been looking at in heat of formation and heat of combustion reactions. Okay, Hess's law states that the heat change of a reaction depends only on the initial and the final stage of the reaction, and it does not rely on the route in which the reaction may occur. Okay, in other words, some reactions go from A to B. Okay, some go from A first to X, some intermediate stage, then to Y, another intermediate stage, and then eventually get to B. Okay, the idea is of Hess's law says that the delta H here is exactly equal to the delta H here. Okay, delta H being the heat change. Okay, so the route or the amount of steps doesn't matter as long as the reactants become the products. Okay, so here you have an example getting from, in the combustion reaction of methane, CH4 with oxygen. Okay, we know that in reacting CH4 with oxygen, we make carbon dioxide and water. Okay, I can do that in one step, okay, going this way, or I can do it in 2 steps. Okay, these 2 steps added together give you the same value. Okay, so either way, that's still minus 890 kilojoules per mole. Okay, so whether I do it in one single step or whether I do the reaction in 2 steps, I will still get the same heat change. Okay, in this case, 890. Okay, so again, this is just another idea. The heat change in going from A to B, okay, delta H or, is the same as the heat change in going from A to X, then to Y, then to B. Okay, so changing your route, go H1 plus H2 plus H3 is still the same heat change as in just going from A to B in the first place. Okay, so some calculations then to look at. Okay, so now we're looking at calculating the heat of reaction. Okay, so what we've had so far is the heat of combustion, which is a reaction with oxygen, and the heat of formation, which is and you'll see it here, the heats of formation, which is compounds formed from elements in their standard states. Okay, these are all elements in their standard states. Okay, so the idea behind this is I want to take this equation, okay, and I want to find the delta H by making the equation CH4 plus 4 Cl2 to give me CCl4 plus 4HCl out of these equations here. Okay, so the idea being that I look at these. So I'm going to take the CH4. Okay, CH4 here is a reactant. Okay, and then I look for CH4 down in my 3 equations. I have a CH4 here. The problem is it's a product. Okay, so because it's a product, okay, I want to reverse this reaction. Okay, so instead of it being C plus 2H2, I'm now going to write it CH4 C plus 2H2. Okay, because now I have my CH4 as a reactant. Okay, which is what I want, given by the equation. So I want to manipulate the 3 equations here to get this equation on top. Okay, so in reversing the reaction, I then have to take the delta H. Okay, and my new delta H now is plus 74.9 kilojoules per mole. Okay, because I've reversed it. Okay, so instead of it being negative, it's now positive. The next thing I want is the 4Cl2. Okay, so I have 2Cl2 here. Okay, and I have another half a Cl. Okay, now that would only get me 2.5. Okay, so I need 2 and I need this to be another 2. Okay, in order to get a total of 4. So what I'm going to do is I'm going to multiply this third equation by 4. because 4 times a half will give me 2. So 4 times a half gives me 2H2, plus 4 times a half gives me 2Cl2, okay, and HCl. Okay, now because I have doubled the equation, okay, I also need to double the heat change, okay, and that's actually the most important bit, is doubling the heat change. So I take minus 92.3 and I multiply that by 4 also. Okay, so the new delta H, so I'm taking this and I'm multiplying that also by 4 because I did that to the entire equation here. Okay, and I get a delta H of minus 369.2 kilojoules per mole. Okay, now the equation that I didn't touch was the middle one. Okay, so I'm still going to use that. C plus 2Cl2, CCl4, and the delta H stays the same because I didn't do anything to this reaction. Okay, now these questions are really nice because if you're correct, then they should work out nicely. So I have a CH4, and I'm actually going to use a highlighter here. I have a CH4. Okay, my highlighter is not working. Okay, I have a CH4, which I want from this equation. I want 4 chlorines, okay, and I have 2 and 2 on the reactant side, okay, which both of those are. And on the products side, I need a CCl4, which I have, and 4 HCl's. And actually, I'm just seeing a mistake here for myself. When I multiplied this one here by 4, I should have also multiplied the hydrochloric acid. So that should have been 4. Okay, which is correct from up here. So I need that. And everything else should cancel. So I can cancel a reactant with a matching product. So remember, reactants on the left, products on the right. Okay, so I have a carbon here on the left and a carbon on the right. So I have a reactant and a product. And I have a 2H2 reactant with a 2H2 product. So that leaves me with CH4 plus 4Cl2, because I've got 2 and 2 of them. It gives me CCl4 and 4HCl, which is exactly what I wanted up the top. Okay, and the delta H I can get by adding up these 3 values. Okay, so 74.9 minus 369.2 minus 139, which gets me a delta H of minus 433.3, and the unit, not to forget, is kilojoules per mole. Okay, same idea with this one here. Okay, I want to make this equation, okay, a methanol, the combustion of methanol. Now, not forgetting that we know how to write this equation even if we weren't given it, because we know how to write the combustion of anything. Okay, so again here I want to look, I have a CH3OH as a reactant. So I'm looking down at my 3 equations. I have it here, but it needs to be reversed. Okay, because I want it on the product side. Okay, so I have CH3OH, which is reversed. So now it's C plus 2H2 plus a half O2, and the delta H, okay, is also reversed. So it's now plus 250. Okay. Then I'm looking at 1.5 oxygens. Okay, I actually have 1.5 oxygens. Here's 1 and here's a half, so that's fine. CO2 here, I want it on the products side, on the right hand side, which I have, and 2 H2O, okay, which is my problem here. I need 2 of them on the product side. It's on the product side, but there's only 1 of them, so I have to multiply that second equation by 2. Okay, now it doesn't need to be reversed, so just 2 times H2 is 2 H2, 2 times a half is 1, and you can write 1 if you want, or you can just leave it as O2, and 2 times water, or 2 times H2O is 2 H2O. Okay, and the delta H for that was minus 286, and I've got to multiply that by 2 also, so now that's minus 572. Okay, so whatever you do to the equation, you then have to do, more importantly probably, to this heat change. Okay, then we have the last equation, which I didn't need to do anything to, okay, which is this one, but I still have to write it down all the same. C plus O2 to give me CO2, which is the heat of formation of carbon dioxide. The delta H of that is minus 394. Okay, and then I want to look at what can cancel, and if it cancels, I know I'm correct. So I know I absolutely need that from here. I need 1.5 oxygens. I'm actually going to come back to the oxygens, okay, because at the minute I have 2 oxygens. I need a carbon dioxide, which I have, and I need a 2 H2O. Okay, so all of those boxed are from that original equation there. They're all parts of that original equation. The rest all has to cancel out if I'm correct. So a carbon reactant cancels with a carbon product, one on the left of the arrow and one on the right. And you can combine the 3 equations. You can work up and down. You can cross off a carbon from equation 1 with equation 3. 2H2 crosses off with a 2H2. And I have a half an oxygen here. So at this point I had 2 O2. If I want to cancel half of an oxygen, so 2 minus a half, that gets me 1.5 O2, which is exactly what I want. Okay, which leaves me with the equation CH3OH plus 1.5 O2 leaves me with CO2 plus 2H2O, and I can get the delta H by adding up these values here. So 250 minus 572 minus 394, which gives me a delta H value of minus 716. Okay, this is actually the most important value, and these are the most important values to get here also.